Welcome to www.happynumbers.org, and this is our third lesson in probability. And remember that probability is the mathematical likelihood that an event will occur, and probability is always a number between 0 and 1, can never be less than 0, can never be more than 1. If an event has a probability of 0, or the probability of the event is 0, then the event never happens. If the probability of an event is 1, is 1, that means the event always happens. Good. Well, let's take a look at a problem here. We're going to toss a coin. We're going to toss a coin 3 times. I want to know, what is the probability that I will get 2 heads and 1 tail? What's the probability if I toss a coin 3 times, I will get 2 heads and 1 tail? Difficult for me to speak properly here. Well, okay, here's a diagram of all of the possibilities. On my first toss, I could get a head or a tail. Suppose I got a head on my first toss. Well, then on my second toss, I could get a head or a tail. And on my third toss, I could get a head or a tail. Or if I toss a tail, I could get a head or a tail there. On my first toss, if I got a tail, my second toss, I could get then a head or a tail. So I'd have a tail and a head and a tail and a tail. My third toss, I could get a head or a tail, or a head or a tail. So, what is the probability I will get 2 heads and 1 tail? Well, what are our total possible outcomes? Well, these are our total possible outcomes. So I have 1, 2, 3, 4, 5, 6, 7, 8 total possible outcomes. But I only want the outcomes that will give me a head, and a tail. Well, I can go head, head. If I go here, that's no good because that's 3 heads. But head, and a tail, well, that's one possible outcome. If I went head, tail, head, well, that gives me 2 heads and 1 tail, so that's a possible outcome. Head, tail, tail, no good. I could go tail, head, head. Well, that gives me 2 heads and 1 tail. Tail, head, tail, no good. Tail, tail, head, no good. Tail, 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 no good. So the desired outcomes that we're looking for are a head, and a tail, and there are 3 desired outcomes. So the probability of tossing a coin 3 times and getting a head, and a tail is 3 divided by 8, and I, with my trusty calculator, worked that out, and it is 375 thousandths, or if we change this to a percent, it would be 37.5% of the time. 37.5% of the time, if I tossed a coin 3 times, I would get a head, 2 heads, and 1 tail. Good. Well, let's ask a different question. What would be the probability if I tossed a coin 3 times? This is the first toss. This is the second. This would be the third. If I tossed the coin 3 times, what would be the probability that I would get a head, and a head? 3 heads. Well, let's take this out. We know that we have 8 total possibilities, but the desired one that we're looking for is a head, and head. 3 heads. So a head, and a head. This would work. But no tail would work. No tail would work. And obviously if I rolled a tail on my first roll, none of these can work because I have to have 3 heads. So it would be 1 over 8. And I've worked that out. to 125 thousandths, or if I made a percent out of it, remember we moved the decimal place 2 places over, would be 12.5%. So the probability of flipping a coin 3 times and getting all heads is 12.5% of the time that would happen. Well, excellent. Let's take a look at one more problem here. Suppose I have a box, okay? And in the box, I have 20 discs. 10 of them are red, 10 of them are blue. Suppose I pulled out, put my hand in, I shook the box up, and without looking, I put my hand in, and the first time I pulled out a disc, it was red. And then I put the disc back in, shook the box up again, and without looking, pulled out another one, and it was red. I did the same exact thing a third time, and without looking, pulled out another one, and it was red. I did the exact thing fourth time, pulled out another one, it was red. And each time I'm putting the disc back in again. Now, what is the probability that on the 5th time I will pull out a red disc? What is the probability that the 5th time I will pull out a red disc? Well, we can just use our little setup here. What are the total possible outcomes? Well, I can have either pull one of these, 10 or 10. So there are 20 possible outcomes. But what outcome am I looking for? What's the desired outcome? I'm looking for a red disc. Well, there are 10 possibilities. So the probability on the 5th try of pulling a red disc is 10 over 20, which is 1/2, which is 50 hundredths, and if I make that a percent, 50% of the time. So 50% of the time then, if I pulled out a disc without looking, it will be red. Now, they'll ask you a question like this. It's sort of a trick question, because you say, well, okay, you pulled a red one the first time, a red one the second, a red one the third, a red one the fourth. It's not going to be a red one the 5th. No, it does not matter. It does not matter. The probability of pulling a red disc without looking is 10 over 20, because there are 10 red discs and the total number of discs is 20, and so it's 50% of the time. It doesn't matter. I could have pulled a red disc 5. On the 6th one I could have got a red one. On the 7th one I could have pulled a red one. On the 8th one I could have pulled a red. And what would be the probability on the 9th time that I pull one out? Keeping in mind that I'm always putting the disc back in again after I look at it, there still will be 10 over 20, and it'll still be 50%. Well, I think that should do us with probabilities then. Let's just do a very, very quick review. Probability is a mathematical statement of the likelihood that an event will occur. It's always a number between 0 and 1, can never be greater than 1, can never be less than 0. And to figure out the probability of an event, we have the total possible outcomes divided into the number of desired outcomes, or the number of outcomes that we are looking for. Well, excellent. Thank you very much for your attention. See you next time.